Now, before you ever create or edit any data, you need to set up your editing environment, and that includes not just vector and raster preferences, but also your general preferences. The general environment includes things like the data size and storage location. You need to make sure if you're going to store data that you have enough disk space, for example, to store that information, not just for the first day, but for the entire project. You need to put some thought into what the coordinate system is that you're going to utilize. Is it for City of Austin? Then you're going to use a locally projected coordinate system. Is it for the state of Texas? And you're going to use a statewide coordinate system. Or maybe it's a specific region of Texas. Maybe you want to utilize UTM and a specific zone. So it really depends on what your project is and what the extent is going to drive your coordinate system. You also might want to set up bookmarks. Bookmarks really automate data capture processes because if you lose where you are, you can go back to it really easily. There's been a lot of times when I've been digitizing data that I've sneezed and I'm like, where in the world am I now? And so it takes me a long time to get back if I don't have bookmarks that frame my AOI or area of interest. You might want to set up your base map with reference layers and layer scale dependencies. So all the data required that will inform your collection of your data. And layer scale dependencies are referred to certain data sets that only show up when you zoom in or zoom out to the data. So for example, if I was looking at crime for the entire United States and I had every incident of crime across the entire United States, I would not want that to draw when I zoomed out to the United States. It would take too long. So I would set a layer scale dependency that only draws when I zoom in, for example, to the city level. Lastly, you need to have a process for backing up your data. And I always back up my data before editing. When I am editing in a project, when I first sit down and open my software, that's typically when I back up my data, not at the end of the process. Because at the beginning, I'm kind of getting configured in. I got my drink open, maybe my snack, ready to go, getting my software set up. It's good time for me to take the extra effort it takes to back that data up. So if I edit it and I actually corrupt or make a mistake, I can get back to the version that I started with at the beginning of the edit session. There are some preferences that you need to configure specifically for raster and vector data, and we'll talk about those next. When you're editing raster data in ArcGIS, for example, you need to set raster and imagery options. You set those options in ArcGIS by going to the project ribbon and then clicking on options, and that opens up the window on the left-hand side of your screen, the options window. And then if you click on the raster and imagery section, you can see various settings that you can set. I often don't go into the options until I'm doing something and I'm like, I really would be nice if it does this, or if every time I added it, it did this. Then I'll go look for the options where I can set that as the default when I first add or open up that type of data. You also need to configure the geoprocessing environment. Again, back in ArcGIS Pro, that's on the analysis ribbon, and then you click on the environments button, and that opens the environments window. Here's where you configure both raster and vector editing environment properties. For example, workspace and output coordinates would apply to both vector and raster, but there are specific sections that apply to vector or raster data. In this case, for example, raster analysis section allows you to set the cell size and the cell size projection method. For vector data, you can set preferences for editing, layer selection editing and snapping, as well as feature template editing. If you click on the Project tab in ArcGIS Pro and then click on Options, it'll open up the Options window. You can see that displayed on the left-hand side of your screen. And if you click on the Editing section, that's where you can set, again, properties for editing. Again, I typically don't start here because I just go ahead and go with the default editing options, but sometimes I'll be doing something and I realize that it'd be better if I automated this process or set the default the way I needed it. That's when I'll go into my editing options. As mentioned previously, you need to set your geoprocessing environment. And so again, the geoprocessing environment includes parameters that are just for raster data, that are just for vector data, and some of the parameters apply to both. And so you need to make sure that your geoprocessing environment is set up correctly. In the software, when you click on the edit ribbon, that basically opens what we call an edit session. And you always want to configure, again, your vector editing environment before you start editing. The first thing I do is set what is selectable, editable, and snappable. And I do that in the contents window. You can see that in the upper right-hand side of your screen. And the default when you open up ArcGIS Pro typically is list by drawing order, but you can also switch the contents pane by clicking these buttons. and change and view the selectable layers, the editable layers, and the snappable layers. And I typically go there before I start any editing session and make sure that only the layers I'm interested in are set that way that I need them to be. You can also configure your snapping environment. Snapping is where you don't have to precisely paste the cursor exactly where you need it. You can use, for example, underlying base map geometry to snap to. And you do that either on the edit ribbon in the snapping button, click the drop down, and you can set what snapping is on and also the various types of features that you can snap to, including points, end nodes, vertices, edges, and various sketch geometries. You can also set the snapping settings, which allows you to set the perimeter or the buffer for where the snapping takes over. And the default is 10 pixels. Sometimes though, I'll turn on my snapping and it's not working. And I'll realize after I go in the snapping settings that somehow it got set to 0 pixels. So I'll go in there to fix that. You can also access the snapping options from the bottom of your screen. You can see there's a little button with a grid and a little plus sign. If you click on that, that's the exact same thing as clicking on the snapping button on the edit ribbon, and you can access all the snapping options from there. Last, we have feature templates for editing. You access feature templates from the edit ribbon by clicking on the create button, and that opens the create features pane. And then when you click on the individual templates or layers that are turned on, for example, in the contents pane, then you can set things like the default symbology, the default construction tool, and the default attributes. And if you don't like the ones that are shown in the create features pane, if you click on that little blue arrow that's on the right-hand side of the layer item, it'll open the active template. And there you can see I can set the default tool and set default attributes, for example. Or I can manage all my templates in one spot by clicking on the button just to the right of the search bar in the Create Features pane. When I do that, I have access to all my templates and I can set them so it preserves those feature templates whenever I'm editing. There are different ways in which we create raster files and geodatabase raster data sets in GIS. We might create new rasters from scratch. We might transform an existing raster to a new raster, or we might classify rasters to create a new classified raster. And so we'll start with creating new rasters from scratch. And in ArcGIS Pro, there are a bunch of different approaches to creating new rasters from scratch, including creating an empty raster, a random raster, a normal raster, or a constant raster. And you can access the geoprocessing tools required to create these rasters from the analysis ribbon by clicking on the tools button. And in the geoprocessing pane, you can see I've searched for create raster, and you can see in my results, I now have access to geoprocessing tools that allow me to create a new raster. So an empty raster is just that. The coordinate system, the cell size, and the extent are all set, but when the raster is created, each cell has a value of null or no data. And so that's why you don't see any cells in the empty raster map view. You can use create random raster to create a raster where, again, you're setting the extent, the cell size, and the coordinate system, but you're also setting, for example, the minimum and maximum values, and then allowing the geoprocess to assign the values to the cells randomly. So in this case right here, in my random raster, I used 1 for my minimum value and 10 for my maximum value, and then created my random raster, and the geoprocess assigned the values. The create normal raster tool also randomizes the values, but does it on a bell curve in which the middle values are going to be more likely assigned to the cells than the lower and higher end of the range. Last, a constant raster is just that. It's a constant value. So sometimes we create rasters, again, of a set extent, cell size, and coordinate system, but we want to assign all the values as a single number. In this case right here, I've assigned all of the cells 1, and so it looks like one huge cell, but it's actually made up of a matrix of cells in there, and each of the cells has a value of 1. Another way to create rasters is to transform them into a new raster. And we can do that by utilizing raster functions or raster geoprocessing tools. Raster functions are accessed on the imagery ribbon. There you can see there's a raster functions button. And if you click on that drop down and click raster functions, it opens the raster functions pane. Those same raster functions are accessible in the function gallery that you can see in the middle of your screen right there. And if you click that or the process drop-down button, you can see that there are a number of those functions that you can utilize to transform your raster from one data set to another. For example, mask would allow you to apply a vector or a raster mask. Let's say a vector mask where you take the shape of Texas and you take a satellite image and then you generate a raster that includes just the part of the satellite image that is in the state of Texas. There are too many raster geoprocessing tools to cover here. You can see, for example, when I'm on the analysis ribbon and clicking on tool, and that opens up the geoprocessing pane. And here I am in the spatial analyst tools. And what you're seeing there aren't even individual tools. They're tool sets, and each of those, contain anywhere from 5 to 15 tools. So you can see that there is, hundreds of raster geoprocessing tools. What I want to focus on in discussing raster geoprocessing tools is how they are applied to transform one raster into another. And they typically are all applied using local, focal, zonal, or global approach. A local raster is where you take an input raster and then you apply a function, for example, or a conversion, for example, if I'm converting all my raster cells from metric to feet by multiplying each one times 3.2, then that applies to each individual cell. That's local. Focal is where you're applying some process, but also an input raster that relies on the surrounding cells to calculate the value of a single cell. So that's called focal or neighborhood calculation, in which you're setting a shape of a neighborhood. It might be a cross like it is in this example, or it could be a circle or a square, and you're also setting the size of that neighborhood. And then the value of the cell that's calculated is based on not just whatever your input function is, but also what the surrounding values are that are found in the neighborhood around the cell you're calculating. Zonal is where you have a couple of input rasters. You have your source raster, and then you have another raster that defines zones in which you want to apply whatever your function to your cells are. And so in this example right here, I've got my input raster, and then maybe I've got a zonal raster that identifies an area as being in a city or not in a city. And then you apply the function to using not just the input function, but also to all the cells that share the same zone, for example. That's a zonal. Lastly, there's global. Global is when you're applying a process and utilizing the values in all the cells to calculate it. So I could, for example, calculate the distance of each cell from the maximum value of all cells in a global raster. So I'd use the global function to figure out what the maximum value is, and then I would calculate the distance from the maximum value for each cell by subtracting that maximum value from the individual value for each cell. Last, we can create new classified rasters from imagery. There are different types of classification and procedures, and there are different combinations of these types and procedures as well. We have a whole class called Introduction to Raster-Based GIS, where we spend a good part of the semester working with different classification types and procedures. But I'll just give you the general overview. The classification types include pixel-oriented and object-oriented. Pixel-oriented is where you're analyzing each pixel in isolation. Object is where you are analyzing groups of pixels that create objects. So pixel-oriented analysis might be focused on, for example, classifying pixels, whether they're grass, water, or forest. But object-oriented would be looking for objects like swimming pools, for example, or airplanes or aircraft carriers, where you are identifying a collection of pixels that identifies that object. Classification procedures include unsupervised and supervised. Unsupervised is where the computer groups the features. For example, I want the computer to group all pixels in a low, medium, and high values, and then I go in and say what those are. This is water, this is forest, and this is grass, for example. Supervised is where the user trains the computer. I go in and I create training samples that say this is forest, this is water, and this is grass, and then the computer goes in and finds the corresponding pixels and groups those together. Now, which type or process you use depends on what you're trying to accomplish. You can, for example, have unsupervised object-oriented classification, or you could, for example, have supervised pixel-oriented classification. If you look at the screen on your right, you can see in ArcGIS Pro where you can access the different ways to classify rasters. On the imagery ribbon, if I click on the classification tools dropdown, you can see segmentation, which is object-oriented classification, or classify, which is pixel-oriented classification. And then when you open those up, you have options to run it as unsupervised or supervised classification. On the analysis ribbon, if I click on the tools button, it opens up the geoprocessing pane. And if you open the image analysis toolbox, you'll see I've got an entire tool set with a bunch of geoprocesses that allow me to segment and classify my data.